Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from differential calculus related to differentiability of functions, right? So here we have one important problem that is discuss the differentiability of f of x is equal to e raised to mod of x minus 1 at x is equal to 1, right? So here we are given a function f of x where the absolute value function is involved, and we have to discuss or we have to test this function for its differentiability at x is equal to 1, right? So now we know that a function say y is equal to f of x is said to be differentiable at some point x is equal to a belonging to its domain when the right hand derivative it exists and it is finite, right? And at the same time the left hand derivative should also be finite and it should exist, right? And moreover the right hand derivative and the left hand derivative both must be equal at this point x is equal to a, right? So once the right hand derivative and the left hand derivative are equal at the given point, then we can say that the function is differentiable and f prime of a it exists, right? So it means a function is said to be differentiable if there is a unique tangent at x is equal to a, right? So here to test the differentiability of this function at x is equal to 1, we'll first find out the right hand derivative at x is equal to 1. So here this point a is 1, right? So we'll first find the right hand derivative, then we'll find the left hand derivative, and then we'll see whether these two derivatives are equal or not. So now let us first take the right hand derivative, right? So the definition of right hand derivative is given by this limit, that is the limit h tends to 0, and we have f of a plus h minus f of a divided by h, right? So this is the definition of right hand derivative. So here a is the point under consideration. So here this point a is 1, right? And here h is a very small quantity, and h is positive, and it lies between 0 and 1, right? So h is infinitesimally very small, right? So now if we take a is equal to 1 here, then the right hand derivative is equal to limit h tends to 0, and we can write f of 1 plus h minus f of 1 divided by h, right? So now let us substitute the value of f of 1 plus h from here by taking x is equal to 1 plus h and then taking x is equal to 1. So we have limit h tends to 0, and we have e raised to a mod of 1 plus h minus 1, and then we have e raised to a mod of 1 minus 1 and divided by h, right? So here we have first we have replaced x by 1 plus h, then x by 1, right? So this is the limit h tends to 0, and we have e raised to a mod of h, and here we have 1, right? Because here e raised to a mod of 1 minus 1 is 0, so we have mod of 0, so this is e raised to 0, and that is equal to 1, where e is the exponential number, right? And see, here we have mod of h. Now see, h is positive, so e raised to mod of h is simply equal to e raised to h. Now this limit can be written as limit h tends to 0. We have e raised to h minus 1 over h, right? And now this is a very famous limit, that is the limit theta tends to 0, e raised to theta minus 1 over theta is always equal to 1, right? So here this limit is equal to 1. So we have seen that the right hand derivative is equal to 1, right? Okay, now let us find out the left hand derivative. So the left hand derivative is defined by this limit, that is limit h tends to 0, and we have f of 1 minus h, or in general we can write here a minus h and minus f of a divided by negative of h, right? So this is the definition of left hand derivative. So now let us take a is equal to 1 here. So we have limit h tends to 0 f of 1 minus h minus f of 1 divided by minus h, right? And similarly here we have calculated f of 1 plus h. Similarly we can calculate f of 1 minus h. So this is limit h tends to 0 e raised to mod of 1 minus h minus 1 minus e raised to mod of 1 minus 1 divided by minus h, right? So this is limit h tends to 0, and this is e raised to mod of 1 minus h minus 1. So minus 1 and 1 get cancelled. So we have e raised to mod of minus h minus and this quantity is equal to 1. So here we have 1 and this is minus h. So we have already seen that h is a positive quantity. So e raised to mod of minus h is simply e raised to mod of h, that is e raised to h, right? So here we have limit h tends to 0 and e raised to h minus 1 divided by minus h. So now we can take this negative sign in front of this limit notation. So we have minus limit h tends to 0 e raised to h minus 1 over h, and again due to this result this limit is equal to 1, right? So here we have the negative sign. So we have seen that the left hand derivative is now equal to negative of 1, right? So viewers, here we have seen that from this discussion that the right hand derivative is 1 and the left hand derivative is equal to minus 1, right? At a is equal to 1, right? That is x is equal to 1. So we can easily see that the right hand derivative is not equal to left hand derivative. Although the right hand derivative is finite and it exists, similarly, the left-hand derivative is finite and it exists, but both the derivatives are not equal. That is, 1 is not equal to minus 1, right? So we can claim that this function is not differentiable at x is equal to 1, right?